Whoa, whoa, no, no, no. Don't print things. Not you. There we go. Alright. We're on. Okay, you started at page, whatever that is, 41. Okay? Now, their tables. Remember, you got to choose your numbers. You got to choose your numbers. Now, I know we were kind of rolling around the room helping. I think I probably worked with at least half of you individually on number 9. Do you remember what the trick was?
Did you like 2 divided by 3 something?
Okay. Oh, as you're making the table, yeah, if I have 2/3 times a thing minus 2, you'd say thing divided by 3, then double it. That way you don't have to think fraction, right? But why did they choose these numbers? Do y'all remember? It's been a long time. I mean, since Thursday. It's been, what, 5, 6 days?
Yeah.
Just because of a long weekend and every other day business. Do you remember why? Why do I choose those numbers and not just -2, -1, 1, 2? Yeah?
Because
What do you mean?
the denominator, and then you always have a fraction.
Okay. If I were to put in a 1, well, 2/3 times 1 is just 2/3. 2/3 minus 2 is -4/3. Y'all gonna be okay with plotting that point? Most kids aren't going to be about that. Most kids don't like fractions. So what we said was whenever there's a denominator in front of that x, pick numbers that are multiples of that denominator. So count by 3s. So they counted by 3s. We still want to have positive and negative if we can. But that's why they had such nice numbers on there. Who didn't do that? And that your table's just full of fractions and decimals. Yeah? I know I worked with at least half of you individually on this one. But once you plot your points, it's game on. We do need to be careful about our scale. That was another thing that we ran into. It's also why I wanted you to have time to work on it in class with a teacher. Because then you'd have time to sit down and work through the problems. Sometimes you can mental math it. Sometimes you have to use a calculator because I just don't want to. Sometimes your numbers are gross because you picked numbers that just didn't quite work out for your x's. Sometimes they give you a graph that has a different scale. You look at number 8, the y's are going by 2. But you look at number 9 and now it's the x's going by 2. And having a different scale really messes with things. You got to be careful how you count out your boxes. But hopefully we got those taken care of since you had like 40 minutes in class to work on it. Okay, next round. Again, you look at number 10, there's no denominator. So I can choose whatever numbers I want. I should probably pick numbers that are on the graph they showed me, which is why they chose to go up through 6. Like, it doesn't make sense to go back to -4 if it's not even on the graph. For number 11, you see it's x over 6. I'm going to be dividing something by 6. I should pick numbers that are divisible by 6. I'm going to have really gross, nasty numbers up there if I put 5. Because 5 divided by 6 is just 5 6, or 0.8333333333333. It's gross. So pick numbers that are divisible by 6 so you don't have to deal with gross numbers. In fact, that's stuff that most of you could probably do by mental math. If I said something over 6 plus 5, what's 12 divided by 6? 2 plus 5. 12, 7. There you go. See, it's nice and easy if you're picking the right numbers. I could pick other numbers. They're just going to give me gross y values. I can still do it. It's just if we can avoid nasty numbers, we're going to avoid nasty numbers. Okay. Then we had some word problem business. Boy, they are just so original with how they write these word problems. The Big Rig Truck Company. Okay. Vroom vroom. $100 plus an additional $2 per mile for rental of its moving trucks. Any ever done the moving truck business? Like a U-Haul, Penske, whatever. Packed it up and had to go. Tell you what, you reach a certain age and buying your buddies some pizza to come help you move, it don't work anymore. So they're like, no, I hurt. We moved, what, 13 times in 11 years? Yeah. So it was something. They give you the function. They give you the equation. You just got to plug them in. Now, a couple of you were asking what numbers should I use? Because if I just choose 1, 2, 3, 4, 5, all of my points are going to be clustered right here. And that doesn't get me anything. So what I told the couple of you that got to this point and were asking in class, pick the numbers that are on the graph. And that's what they did. They picked 10, 20, 30, 40, 50 because that's what's on the graph. Also think about it in terms of the problem. Are you going to pay a moving company to go 3 miles?
No.
I'll just throw crap in the back of my truck and go back and forth. Okay? But if I'm going to move from here to Rapid,
Yeah.
all right, it's probably worth getting the bigger truck, right? Get the U-Haul, fill her up. And then you plug those in. Again, they're nice numbers. What's 2 times 40?
180.
No,
80.
80. Then plus the 100.
180.
There you go. Well done. Okay. And then they say to do the same thing at 50 miles, but you're just going to plug the number in there anyway. They do the same thing. Here's a function. Plug stuff in. I look at the graph at the bottom on my x-axis and I see 1, 2, 3, 4, 5, 6, 7. I should probably pick those numbers and not -5. Right? Because it's what's on my graph. I hope that we're not afraid of word problems. I know that kids usually, word problems don't go well in math. And then you just kind of get this, like, people overuse, they'll say, I have PTSD about thing. A, don't say that. B, if you actually have PTSD, you know that it is legit a debilitating thing. 3, I would not be surprised if we had multiple people in this room who literally have PTSD related to math. Literally, okay? What it means is you have a trauma response to the subject because somewhere along the way, you did math and felt really bad. Whether you tried your hardest and failed, whether you tried and someone made fun of you, maybe you asked for help and someone made you feel dumb. Like something like that happened enough times that you were just like, F it, I'm done. I'm just not going to. It's an actual trauma response. I don't like feeling this way, so I'm going to avoid it so I don't feel this way again. Which is why a lot of kids just kind of shy away from word problems. Word problems make me feel bad about myself because I don't understand them. That's why you ask. That's why you're in this class. I want you to ask questions and get help. I want you to work through it together with us. If I see this problem and I got a big honking equation here and it's just alphabet and number soup, then maybe I ask for help reading it. The cost in cents. So this is cents, 0.01. So what does that mean if I have 120 cents? $1.20, right? 120 cents, 120 pennies. It's $1.20. Okay. So maybe I just get rid of all this. Okay. That said this. These are pennies. The cost is blah, where X is the weight in ounces. Okay. Y'all ever actually mail something? Like not just shove something in a mailbox. You go to the post office and you hand them a larger than usual envelope or a box. What's the first thing they do? They weigh it. They put it on their scale, right? Because how much it weighs determines how much it's going to cost to send it. Now, I'm betting it ain't $1.20 anymore. This is an old book. But I'm going to plug those numbers in because that's what's on my graph. Now, there is absolutely nothing wrong with letting the calculator do every bit of this for you. That's what I showed you last week. I was hoping we were okay with it. That's right, I restarted my computer, so I got to move this over. Come on, Frank. Good job, Frank. So I can type this exactly as it is if I got a right view calculator. 17, a parenthesis, and I'm going to plug numbers in for X. Maybe I'll start with 1. Stick a 1 minus 1, parenthesis, womp, and I get answers. Oh no, it tells me to quit. I should just give up on math, right?
Yep.
Now,
Play Goto.
let's play Goto.
Yeah.
Okay. If you ever run across error syntax, syntax is the order you say things in. Like, Yoda had really weird syntax. Finish your lunch, you must. Okay? The order he said things in was weird. They said, yo, you typed something weird. The way that you typed it is out of order. It's messed up. So if I say go to, it'll literally go to where I screwed up and say, hey, Putz, you didn't actually hit the rest of the numbers. It's supposed to be 1 minus 1.
Why is there a nether portal in the top corner?
A nether portal?
Yeah. You see Minecraft. We just went in.
You mean the little one up here?
Yeah.
Oh, that's the thinking. Okay. If you're ever using the bumblebees in class, the yellow circle means I'm thinking. That also means don't press any other buttons. Imagine if I came up to AJ here and I said, all right, I want you to answer this question for me right now. Is he going to be able to think very well if I keep poking him while he's trying to think?
No, but computer.
Okay. This device, if you keep poking it while it's thinking, you might turn that yellow circle of doom into the white circle of death, which is it's literally frozen. You froze the calculator. Good job. Okay? Please don't do that.
How do you manage to freeze a calculator?
Because you were poking it while it was trying to think.
Don't poke the bear.
So, y'all, you okay with just coming up here? If you're using these kind of calculators, you can just highlight it and hit enter. Put in the next number. Let the calculator do the work for you.
Oh, that's so much better than retyping.
Poke the thing. Say, now it's going to be 3 minus 1. Keep doing that to get your table, and then plot your points. Okay? Then it's going to ask what? How much does it cost to mail something weighing 5 ounces? I'll just put a 5 in there. And I get my answer. Okay? Don't be afraid of word problems. We can help you set it up if you're okay with it, if you're willing to, try. Hey, you. Okay. That was what we just did. There we go. Vocabulary. All right, so now, legitimately, I won't poke you this time. Okay? We're always good with the vocab because just going back to the front page and answering the question because you copy down what the vocab says. But at the end, can an equation be created to model every relation? A relation is just a mapping. An equation or a function is a very special kind. See, if I had a graph that looked like this, could I create an equation that hits that perfectly? Sure can. I teach algebra.
So familiar from somewhere.
I teach algebra 2 and pre-calc. Yeah, I can do that. What happens if instead of that, the mapping that I give to you looks like this? Can you make an equation for that?
Yeah.
Okay. All thumbs are fingers, but not all fingers are thumbs. All thumbs are fingers. Is this a finger?
Yes.
Yes. But are all fingers thumbs?
Yeah. Yeah. I mean, if all thumbs are fingers, then all fingers are thumbs.
What?
It's the difference between a conditional versus a biconditional statement. You'll talk about it in geometry next year, but if Paxton speaks, someone hits him.
Micah. No, that's AJ.
No, that'd be me.
He hits me all the time.
Does that mean that if someone hit Paxton, He must have spoken.
Yes.
No. Could just hit him because you want to. So,
Can I do that right now?
no.
And I'll smack you too. Yeah.
That's what this says. Not all relations are functions. I can make an equation for a function. Oh, that was the door. Okay. I did too. Not all relations are functions. Only functions can have equations that we know of yet. You got to get to some pretty wicked math to do non-function equations. So, there you go, folks. I would like you to make a table and graph that equation. I intentionally didn't use something with a denominator. Yes. It was my intention to not use a fraction. There is no way you can get fractions here unless you put fractions in. Yes. Yeah? Then go. You could have just asked. Okay.
Yeah, my T-Rex arms.
Come on. Get it? Where's your notebook? Or your folder, or wherever you put these. Problem solved. Now do your math. Besides, you can always go up to a corner and just Yogi Bear that stuff. Make a table. I'll tell you that this entire graph can fit on here if you pick the right numbers. Don't pick wild numbers. Pick numbers that are on this space. Okay? I've been walking.
Can you help me with this guy? How do you put that according to the calculator?
Times that platform. Go up.
Wait, you did all.
Negative 2.
So,
Guys, this is a quiz, we're not working together.
it's helping me with the calculator.
Because that's something that we can do before the quiz test.
Well, you couldn't really do it
And we
because
can ask teachers. We don't ask each other, we don't look at each other in quiz.
Asking questions. Teachers think he was What was that? Joe. That was Joe. Joe Mama. Paxton, we have the twins. The joke's like weird how quiet.
I'm scared. I'm walking around, getting kind of scared. Make a table. Pick numbers, preferably numbers that are somewhere in the center of that graph. Plug them one at a time in for x.
Oh, no.
No drugs.
Can't be popular because
I can if coffee tastes like crap and I still want to stay awake. Sound like you're strangling Wilbur. That's how we make bacon in this house. So, I got a table all set up and ready to roll. We've had plenty of time. Okay. The numbers that I will personally pick, well, if I don't see an x, if I don't see something over a denominator, if I don't see a fraction in front of an x, then I get to pick whatever numbers I want. Those are not numbers. Those are gibberish. Instead, I'm going to just pick the numbers that are right smack in the middle of the graph. Now, that's what I chose. Did you choose anything different?
I did not understand
Okay. So you're picking x's. I'm saying right here at -2, where is the y? Shove a -2 in there. What's -2 times -2? +4 plus 4. 8. So the coordinate is -2, 8. So if I press the -2 button, it'll give me 8, which is way up there. I can't even fit it on my graph. So I keep going. Next, I'll try -1. See what happens. What's -2 times -1? +2. 2 plus 4 is. So at -1, I'll get 1, 2, 3, 4, 5. You know what? I'm going to go a little off-road for that one. I'll go one off-road. I'm okay with that. Now, you all got to make your own graph, so you should have been able to do whatever you wanted. And I keep running down the line. -2 by 0 is 0. 0 plus 4 is 4. So at 0, 4. -2 plus 4 is 2. So at 1, 2. -4 plus 4 is 0. Or, were you able to see the pattern after so long? If you see the pattern says it's going down by 2 every time, then I'll just go down by 2 every time. Do I got enough dots up there to make a line?
Yep.
Yep, do it. There we go. Score them up and score them up honest. Did you have a table? Did you pick X numbers that weren't ridiculous for your table? Did you get Y's for each of those X's by doing math and stuff? Did you plot your points, and then finally, were they the correct points? Okay. It's all about that process. Score it up. Okay.
So when I did it, I forgot to add that little minus at the on the 2. But
So did you have this same line, but right here going that way?
Yeah.
4 out of 5.
All right, thank you.
This is what I mean by asking questions. Ask questions about your daily quiz too. Like, you say, yo, I did all of that, but I kind of missed that negative entirely. So my graph looks like this instead. Okay, you missed the negative. 4 out of 5. You still have the table, the X's, the Y's, the graph. You just missed the negative. Oh well. I'm totally cool with that. What? Who do what? Okay. So, went over stuff. We did daily quiz. Let's see what y'all got. 'Tis been 5 days. That means dun, 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 dun. It's quiz day. Reminder. We can put these away. A reminder that you get to use this on your quiz. I have started printing them separately so that you don't have to flip around. Also, there's a couple extra problems on the back because I think we can do okay with 10 in here. They're not terrible, not too tough. I always time these. I time them when I make them. So if they take too long, I alter the test. So you should have more than enough time to do this in class. We go and review. As we review it, you're following along and you're writing notes to yourself. You get to, it's open notes, open everything on every quiz. So if we're going to review something that looks exactly like the quiz right before you take the quiz, maybe you should write stuff on the review for the quiz to tell yourself how to do the quiz. Okay? All right. Can I who what? Not while we're doing the review. We're doing the review together. All right. You go away. You go away. You get up here. There we go. All right. So starting off with one of the last things that we did, we had a little bit of that simplifying business. You're going to see throughout the year, I'm going to keep bringing back old stuff. It's not enough to just work on new stuff. Did I miss you? Did I not give you one? Okay. It's not enough to just work on the new stuff. We have to keep bringing back the old stuff so we don't forget it. I'm telling you, I have done math that would actually make your head explode. I don't know how to do it anymore. It's been too long. I have kids who finish pre-calc with me and they go and do calculus with Mr. Spear. And they come back and try to ask me questions and I laugh at them and say, you know when the last time was that I did a differential equation? No. Was this rhetorical? Said, I started in Calc 3 as a freshman in college. I haven't touched a differential equation since 2004. I don't have students that old anymore. So, like, math is a thing that no matter how good you are at it, you're going to lose it if you don't use it. Okay? So we're going to keep bringing stuff like this back. Does anyone remember, how do I simplify a radical? We kind of spent 5 days on them. Yes, sir.
So one of the strategies that we did was just branching off from the 80.
And I think that's what most of you preferred. Y'all remember that? Shoop, shoop. What times what makes 80? 10 times 8. Okay. What times what makes 10? What times what makes 8? Okay, can I break any of those up? Remember, we're trying to get to prime numbers. Okay. That's as far as we can go. I'm going to look at the ends of the branches. Say you, and you. So I have, instead of square root of 80, I'm going to say square root of 2 by 2 by 2 by 2 by 5. Do you remember what our trick was with variables? Yeah?
Shoes go fight the guard. One lives. Makes it out.
Okay, that's how I'm going to get those out. What about the variables? I want to finish writing it before I start taking things out.
10 X's.
Okay. If you want to write this out longhand, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X's and 1, 2. But I tell you what, if you've got 10 X's and only 3 reasons why, then maybe you deserve to have 10 X's. Then, Landon said, we look for pairs, right? Something squared is something times itself. So, a pair of 2s rush the guard. Only one gets out alive. A pair of 2s rush the guard. Only one gets out alive. Oh boy. A pair of X's, pair of X's, pair of X's, pair of X's, pair of X's all rush the guard. And 1, 2, 3, 4, 5 of them get out alive. You keep looking for pairs. A pair of Y's rush the guard. One gets out alive. This is the long way. There is a shorter way. But this way will always work. If you are beyond stuck, this way will always work. Okay. Now, talk to me, Kevin. What do I do with all this junk outside?
You can add both to make it a 4.
Well, I multiply them. It just happens to also be 4. Yep.
And then you have 4 to the 5th power.
No. This is 4. What is 5x's multiplied? X to the 5th. And then this lonely little y. Now what? Right? You look at who's still left in jail. To get out of radical jail, you needed a buddy to rush the guard with. Well, 5 and y, they don't have any friends. So they're just going to stay there in radical jail. Nope. They got nothing in common. They hate each other's guts. Sorry. This was one way to do it. The other way, a little more sophisticated, was, remember our perfect square list? You run down the perfect square list starting below 80 and say, what? What?
2, 3, 5, 7.
Oh, those are primes. Our perfect squares.
1, 4, 9, 6,
There you go.
6.
We wrote down all of our perfect squares. I want to find what is the biggest perfect square that goes into 80. And it happens to be 16. No, like I start right below 80. The biggest perfect square below 80 is 64. So then I look 81 divided by 64, or 80 divided by 64. Nope. Divided by 49. Nope. Divided by 36. Nope. 25. No. 16. Yay! 16 times 5. You notice we got an x to the 5th out of x to the 10th. What did we do? How many pairs of x's go into x to the 10th?
5.
Right? How many, like, you ever played that game, like, if I'm really, really trying to lie, How many ways can I cross my fingers? Right? Well, 1, 2, 3, 4. I feel like I'm throwing up gang signs in math. Here we go. 5. There we go. Okay. So that's what you're doing. You're looking for pairs. Okay, that's pretty clever, actually. Since x to the 10th is an even exponent, I'm going to leave it because that means I can just cut it in half. Y to the 3rd, though, I'm going to say y to the 2nd and then shove that other y off to the side. This is just a faster way to do it if you know your numbers. Because now the square root of 16 is 4. The square root of x to the 10th is x to the 5th. The square root of y squared is y, and look at who's left. So if you're good with your numbers, if you know your perfect squares, you can do that instead of all that writing. Both are correct. I don't care which way you do it. They are both correct. Can I erase the thing, or are you going to freak out? Okay. Make sure you're writing this stuff as I'm writing it so we don't have to pause and wait, because every time we do, we're just losing time on our quiz. Okay. Same thing. What times what makes 48?
6 times 8.
6.
3 and 2.
8. Any of those?
4 and 4. Could go with 2 and 2.
Okay, so I have a plus or a minus 5, a square root of 1, 2, 3, 4 2s, a 3, x to the 11th. I want this to be an even number, so instead of writing out 11 x's, which you can do, I'm okay just doing this. Right? X to the 10th, that's an even number. I can cut that in half. I just got this other x hanging out. And take out pairs. There's a pair of 2's, 1 gets out. There's a pair of 2's, 1 gets out. How many x's are coming out? 5 of them, right? Cut it in half. So everything that's outside gets to party together. 5 times 2 is 10. 10 times 2 is 20. X to the 5th. Square root of, there's still a 3 and an x left inside. The only thing that was different about this is there was a 5 outside, so everything that came out parties with 5. And because it has this plus or minus, that also has to be a part of my answer. Okay, so you can write it out the long way if you need to. Or, if you're good with it, the way that I like them is I'd say the square root of 16 by 3 by x to the 10th by x. Because square root of 16 is 4. Square root of x to the 10th is x to the 5th. That still multiplies together to get the same thing. It's faster. But being faster requires thinking more. Okay. Think about, anyone done your own home PC build? You got to spend money, right? You got to spend money if you want a faster processor, if you want a better graphics card. It takes more to get more. You got to think more if you want to do it the fast way. Okay, so that's a little bit of review onto our relationship and function stuff. Domain and range. Y'all remember what domain is? X's. So X's gets me my domain, and you said it, Y's are my range. So if I'm going to list out all my X's and Y's, I think a lot of us did better if we wrote the coordinates first. If we're going to write the coordinates, we should probably put that handy-dandy cheater right next to this. Right? X then Y. X's go this way. Y's go this way. So, someone tell me, where is that?
0, -3.
From the origin, we go back 3. So, -3 in the X spot.
Oh, then 0.
And then no up or down, so A is at -3, 0. Same thing, what about B?
-3 and
-3, -4. Or never.
Do your left or right first.
-4, -3.
Left 4,
Down 3.
down 3. So we'll call it -4, -3. Okay. C. No left or right, up 2. And D. Right 1, down 2. It got kind of squished together. I don't like that. There we go. So if I'm writing out my domain and range, it's as simple as list all your X's, then list all your Y's. List your X's. Some of you, that might be a painful experience. -4, -3, 0, and 1. Range. List the Y's. I see a -3, a -2, a 0, a 2. Domain and range. Okay? X's and Y's, domain and range. Does it help to have the coordinates instead of just trying to wing it off the graph? Some kids are okay with winging it off the graph. If I don't have those coordinates, I'm not doing the whole thing, just this part. Some kids are okay with this. Get a pencil or fake ID and scroll across to your x-axis like this and say -4, -3, 0, 1. As I go across, those are the numbers I hit, so those are my domain. Knock it off, both of you. Do the same thing for your Y's, just tilt it on the side. Someone just step on a Yorkie? Okay. Same thing's happening here, except the coordinates are already listed for me. Oh, pay attention to the directions. What did it say? Mapping, not just list, domain, and range. The mapping is where I have my domain and my range, and then I connect the dots. I cross my wires, okay? So start with all of your x's. X's are always first. You can write them exactly as it says here. Personally, I prefer putting them in numerical order. The lowest it ever goes is negative 11. Then negative 6, negative 3, 0, and 1. Next, I'll list out all of my y's, because y's make range. Do you remember the rule? You don't have to say it more than once. You don't have to say it more than once. You don't have to say it more than once. Okay. So I'm going to put down a 8, 11, and 21. Yeah, I listed my domain and range. That's great, but I haven't finished. Draw a mapping. Mapping means cross your wires. Maybe that's something you should tell yourself so you don't screw it up on the quiz. Actually cross the wires. Draw your arrows. Negative 11 went to 21. Negative 6 also went to 21. Negative 3 goes to 11. 0 goes to 21. Jeez. And 1 goes to 8. Mine has that like cat's cradle looking mess. Maybe yours didn't. That's okay. As long as they're connecting the correct pieces. We good? Hearing no objections, the motion passes. Determine. Okay, it's not enough to just have a relation. When is the relation special? Determine if this relation is a function. Why or why not? You tell me. How do I know something's a function or not a function? Okay. I forget who it was we were working with, but if I have this versus I have this, which one of those is okay? To be a functional machine, I press this button and it only does what that button does. This, I pressed the Mountain Dew button. It gave me a Mountain Dew, but then it also gave me a Coke. Is that a functional machine? No. I press the Mountain Dew button. It gives me a Mountain Dew. I press a different Mountain Dew button. It also gives me a Mountain Dew. Yeah, they're each doing one thing. Yeah, what was that? We had a sub here that day, and they said it really good. It was something with the fingers.
We never had sub.
Not sub for me. It was something like one of those was okay and one of those wasn't. I forget how they said it, but it sounded really good.
Oh, it's okay, it's not.
Oh. There was an actual word that went with it that made it make sense instead of just "nyeh." So I don't know. But what I would like you to write, come on, this is bad. This is good. And this is also good. Okay? That's how you know if something's a function or not. Every x has to go to exactly one y. Look at the x's in the table. Do I have an x that goes to more than one y? Does a 6 ever go to both a 20 and a 12? 1 goes to 2. There's no other 1s. -3 goes to 6. There's no other -3s. 8 also goes to 6. Can I have 2 different Mountain Dew buttons on the same machine? Yes, I can. There we go. -8 goes to 5. 20 goes to 11. I only pressed every one of the X buttons once, so is it a function? Yeah. Because every X maps to exactly one Y. Every X goes to one Y. Technically the definition is every element of the domain maps to exactly one element of the range. I can only say that if I actually have a graph. Now, if you want to make a graph of this right next to it and then say that, go for it. But I think it's overkill. It's like deer hunting with a bazooka. Okay?
Yeah, but then you actually hit the deer. No
I'm
matter
sure
what.
it'd be
What are you going to eat?
I'm sure it'd be
Deer.
disintegrated by the time you get to it. Either disintegrated or
Okay.
all over the forest.
Actually, the whole like using explosives to cook, they tried that on Mythbusters.
Didn't go so well.
No, because it flash fries the outside and the inside's still cold. So remove head from rectum. Let's do math. Okay? Is this a function or not? Okay, now Shane. Now is your time to shine. Is this a function or not? Why? There you go.
I don't even need I basically don't even need a parking second.
Right? Just show that line, and whether it's your fake ID or whether it's your Qdoba gift card, it's a pencil, it's the edge of your calculator. You run it across the graph like this and say, well, it never hit more than 1 point, so I guess we're good. And that's exactly how you write it too. You say, yes, it's a function because it passes the vertical line test. I can only say that with graphs though, not with anything else. Okay, the back. I don't want you to worry about yet. Okay? I honestly don't want you to worry about the back yet. Because A, I know that we need more practice with 1-7. We're going to do that on Thursday. I want to have more practice with it before it's actually in a quiz that goes in a gradebook, particularly right before the quarter. Okay? B, I think we're going to need to do a little more practice with our exponents before we go reviewing that and putting it on a actual quiz on a gradebook. Okay? So I'm going easy on you here. You get about 20 minutes to do 6 problems. Open notes, open everything, except phones over here. All your devices, go over there.